In this video, we are going to talk about different angle relationships, how to identify them, and then how to solve problems based off of these relationships. So, the first type of relationships that we have are complementary, supplementary, vertical, and adjacent. Complementary angles just mean angles whose measures add up to 180, or 90 degrees. Supplementary are angles whose measures add up to 180 degrees. Vertical are angles who are non-adjacent, so not touching, and you can think opposite of each other. Adjacent angles are angles that are adjacent to one another, who are touching or have a shared line with them or array. So looking at some of these relationships here, number one, A and B are not adjacent because they do not share a particular side, or you can think of it as they are not touching one another, they're not together, but they are opposite from one another, and so these can be defined as a vertical set of angles, vertical angles. So then for number two, A and B, they do share this ray in the middle, and they're touching one another, so we can say they are adjacent. Now, what we also know is that A and B are on the same line here, and they form what's called a linear pair. And based off the linear pair postulate that we've learned, we know that linear pair angles are also supplementary. So since these adjacent angles are a linear pair, we can also conclude they are supplementary, which just means that their angle measures add up to 180. Number four, we see that A and B are in the middle of a broader angle, which is 90 degrees, which is marked by this little box. So we can say that A and B are complementary because their angle measures will add up to 90 degrees. Looking at number six now. A and B do not add up to 180. There's no markings to say they add up to 90 degrees. They are just angles that share a side and are together. They're next to one another. So we can just say that they are adjacent. Back up to three, we see that A and B are non-adjacent and are opposite. So once again, a vertical pair of angles. And then for number five, we see that A and B are on the same line as this angle measure here, which is 90, meaning A and B has to also add up to 90 to make all of these a set of linear pairs. So what we can say from here is that A and B are complementary. So now the next set of angle measurements, or angle relationships, are what's called alternate interior, corresponding, or alternate exterior. So looking at these sets of lines here, let's first define alternate interior, corresponding, and alternate exterior. So given that I have two lines and a transversal, which just means a line that cuts them, the alternate interior, so alternate first means opposite, and interior would mean inside. So looking inside these two lines that you can kind of think of form a house, the alternate angles are on opposite sides, and so one of the pairs of alternate interior angles are marked by AI. Then let's look at corresponding angles. Corresponding angles are angles who correspond to one another. So given that I've marked here with C, so given this angle on the exterior of this line, it corresponds to the interior of the interior angle here. And so these are corresponding angles. So alternate exterior, alternate meaning opposite, and exterior meaning outside, you can think of the outside angles and their pairs that are opposite from each other, which I've marked here with AE. So let's look at a few of these. So looking at number 7, we see that these two lines are cut by this transversal over here. We can ignore this line over here. And we have A and B. Alright, these angles A and B are not, both angles are not inside or outside of these two parallel lines, which we know they're parallel based off of these markings. And since they're not inside or outside, we can see that they are corresponding. Looking at number 8 now, we have these two parallel lines cut by a transversal. We see that B and A are both inside my set of parallel lines, and they are also opposite angles, so they are alternate interior angles. Looking at number 9 now, we see that these lines are the parallel lines we need, cut by this transversal. And notice A and B are outside of my parallel lines, and they are opposite angles, so we can say these are alternate exterior angles. And now looking at number 10, we have a set of parallel lines cut by this transversal. A and B are not inside or outside of my parallel lines, so they are corresponding. And since they're on the same side of the transversal, that's how we really know they're corresponding. If we had angle B over here, A and B would no longer be corresponding. So why would we learn these relationships, you're probably wondering? Is because these three relationships are part of theorems and postulates of parallel lines that tell us that these angles are congruent, which means they have the same measure. So most of these start out formally by if two parallel lines are cut by a transversal, these three types of angles are congruent. So let's use that knowledge to figure out some angle measurements. So over here on the back on number 11, or rather let's look at number 12, we see that we have two sets of parallel lines cut by this transversal. We see that 60 and the measure angle B are alternate exterior angles. And since they are alternate exterior, we know that they are congruent, so B is 60 degrees. Another example of this would be number 16. Looking at the two parallel lines cut by this transversal, we see 85 and B are inside my parallel lines and opposite sides of the transversal, and so they are considered alternate interior angles, which show they're congruent, which means B is equal to 85 degrees here. The rest of these you should be able to solve using the various angle relationships we talked about in this video.